guys, wave-particle duality, properly amazing. And if you understand it, you're like way ahead of the game in physics. It is confusing, right? How is a particle supposed to be both a wave and a particle? It's supposed to blow your mind, right? It's crazy, it's fascinating. And what we can see is there's a really cool YouTube video, okay? So it's an animation video. It's about this like white old physicist, and he's animated and he fires this beam of electrons at a double slit. Highly recommend you watch it. And if you want the link for it, just comment in the chat, or if anyone else has a link, just post in the chat. It's really good. But you are supposed to be mind blown by it. So what we observed is that if we have a double slit, so a double slit is basically like, imagine a little film, like old fashioned films. And basically, instead of that film being solid, we just put two slits inside it. So that two slits are like two gaps that if we shine light in it, the light can come through these two gaps. But what we're going to do instead of shining light is that we can shine a beam of electrons at these two gaps. Okay? And the cool thing with that video and what it shows you, what physics is, the reality of the observations, is that if you're here in the room watching this happen, if you're watching it happen, you're forcing the electrons to behave as particles, to behave as electrons, which makes sense. If they're little particles, they can either go through the top slit and they're going to hit the screen here, or instead of going through the top slit, it might go through the bottom slit and hit the screen here. So all electrons then, when they pass through, when they come along, they go for the top one or the bottom one, top one or bottom one. And then on the screen, you're just going to see this big bright spot here and a big bright spot here. So this is my screen. Okay, but if we're not in the room, what happens then is something completely different. So what happens if we're not in the room, the electrons actually behave as waves, right? So now they're going to behave as waves. We have this coherent waves. Comment below if you know what coherent is. So we have these coherent waves. And what happens then is they have an equal probability of going through both waves, both of the gaps, okay? And we know when waves, when they hit the gaps, what's going to happen is we know we're going to get interference. So they behave as waves now. We know they're going to diffract, right? The waves spread out, and we know that they're going to interfere. And we know that when they cross each other, because this point here is the exact same distance away, we get constructive interference, which is a bright spot. And then what happens is we get alternating, pardon me, can't speak. We get alternating parts of bright and dark fringes. So if I'm marking, these my X's are all these like bright spots I would see on the screen. So on the screen, you see loads of bright spots because when you're not present in the room, there's no detector, the electrons behave as waves. And you get this interference pattern because they superpose. Okay, so the question says, this is the wavelength of my electron, and it's hit at atoms. So we know it says here the atoms, it says the atoms have a gap between them of 0.1 nanometers. Okay, so 0.1 nanometers is 0.1 times 10 to the power of -9, or